Hello grade 10s and welcome back to a new video with me, Miss Martins. Today we're going to go over some chemistry exam multiple choice questions. But first of all, I just wanted to share these multiple choice tips with you. Always answer your multiple choice questions, even if you have to guess. I've been marking, it is exam time, and unfortunately I do see learners who leave multiple choice questions blank. If you have 4 options, A, B, C, or D, you have a 25% chance of getting it correct. So even if you have no idea, please guess. My second tip is instead of focusing on which of the options are correct, eliminate the incorrect ones first. Sometimes in a question, there'll be one that is absolutely incorrect and you can see and you know because of what you studied or whatever, you know, okay, I definitely know that one is not right. Maybe you even eliminate a second one that you know is definitely not right. That narrows down your options and it increases the possibility of you picking the correct option. So I know sometimes it can feel overwhelming, but just take a deep breath, eliminate the incorrect ones first, and then maybe the answer becomes clear to you. And the third tip is more applicable to grade 11 and grade 12 learners. It may apply to grade 10 physics and chemistry in some cases, the more difficult questions, but you always have to look at your formulas, your formula sheets, your relationships between your variables in order to answer certain multiple choice questions. So this one, 1.1, says which one of the following substances is not a pure substance. So if it's not immediately clear to you, remember we're going to do process of elimination. But now, first of all, what is a pure substance? As I go through these multiple choice questions, I'm not just going to answer them. I will expand and explain the theory and the reasons behind my choices. So iron is Fe. Let's just go back to my question, what is a pure substance? So pure substances are elements or compounds. Remember, elements are all the things that you find in the periodic table. Compounds exist when we combine one or more types of elements together in a fixed ratio. So iron is definitely a pure substance. So that's definitely not one of my answers. Some people get confused with sugar. I'm going to come back to sugar. Graphite's also another interesting and confusing one. But basically, what graphite is, it is a crystalline form of the element carbon. It contains rings of 6 carbon atoms. So graphite is also definitely a pure substance. Okay, it's a form of carbon. Still, some people in error think that steel is an element that they find on the periodic table. It's not. Steel is actually what we call an alloy. It is a mixture of iron and other things like carbon and then other smaller percentages of other metals. So steel is what we call an alloy. It is what we call a mixture. It is a homogeneous or homogeneous mixture because it's of uniform composition. You can't tell the individual components apart. So steel is actually the answer in this question. Steel is a mixture. Sugar, however, always throws people off because people forget that sugar is actually also a pure substance. It is a compound. And if we talk about pure sugar, basically that is sucrose and its chemical formula is C12H22O11. You don't need to know that. It's just, you know, it's just interesting. So it's definitely a compound. It's containing carbon, hydrogen, and oxygen. Our next question, they say the correct chemical formula for potassium nitrate is. Now, before we even get confused by our options, what we can do is we can work it out for ourselves. But immediately there's an option that's bothering me over here. You should know that potassium is K. So the option that is completely wrong is B. Okay, potassium is K and nitrate is NO3. That immediately eliminates this option. Now, obviously, if you didn't know that, that option wouldn't be eliminated, but just remember that potassium nitride, so if I had to spell it like this for you, potassium nitride, that will represent potassium being K and nitride is N. But nitrate, the nitrate ion is NO3. Now, the charge on potassium is +1. How did I know that? You go to your periodic table. We know that our group 1 metals, our alkali metals, have a charge, have a valency of +1. This is +2. This is +3. This is ±4, -3, -2, -1, and 0. Those are my charges or my valencies. So potassium is +2. And nitrate is a polyatomic ion. And we should know, or you should know, that the nitrate ion has a charge of -1. Okay, you need to learn the charges of your polyatomic ions. Remember, when we form a compound, this must be a neutral compound, so the charges must equal 0. +1, -1, yup, that gives me 0, so therefore it's KNO3, which is option C. 1.3 says different isotopes of the same element have different. Now, you should have studied isotopes. An isotope, for example, chlorine and chlorine, we can have chlorine 35, for example, and we can have chlorine 36, for example. We can see that they have the same atomic number. Okay, so atomic number is definitely not the correct answer. They have the same atomic number, and we know that the atomic number is the number of protons. So it's definitely not that option. We also know that in a element, in an atom, so basically not an ion. So we're not talking about the chloride ion here, we're talking about just the atoms. So this is an atom of our element, that's another atom of our element. They will have 17 being the atomic number, also being number of protons, also being the number of electrons. Isotopes don't have a different number of electrons. They have a different number of neutrons. And because their number of neutrons is different, that is why their atomic mass number is different. So remember, neutrons is your atomic mass number minus your atomic number. So 35 minus 17 and 36 minus 17. That's your number of neutrons. So you can see here that the number of neutrons is different for isotopes. Our next question says, which one of the following statements is incorrect? So read the question carefully. It says incorrect about the properties of a physical change. When a physical change occurs, the compounds may rearrange themselves, but the bonds in between the atoms will not break. This is true. We know that during a physical change, there's no breaking of bonds. We're not forming a new substance. So that is true. Physical change in matter is reversible. We know that that is also true. For example, if we melt a liquid, it can go backwards and it can freeze again. Energy is absorbed when matter changes from a solid to a liquid. That is also true. Molecules are not conserved during a physical change. That is not true. So what that means is if I have one molecule of solid water, they're saying that that will not give me one molecule of liquid water. Okay, no, that is definitely true. If I have 2 molecules of solid water, it'll give me 2 molecules of liquid water. So molecules are conserved during a physical change. So that means our answer for 1.6 is D, because it is the statement that is incorrect. 1.7 is an interesting question. I want you to pause the screen and see if you can get it for yourself. But it says in the compound H2O, the ratio of the mass. And do you see how they capitalize mass? They're giving you a massive hint. If they capitalize something, they're drawing your attention to it. So they say the ratio of mass of hydrogen to oxygen is always. Now, when people see this question, they get excited because they say H2O. Ma'am, I know hydrogens, there's 2 of them, and oxygens, there's 1 of them. So therefore, the answer must be B. Look at what the question says again. They say the ratio of the mass of hydrogen to oxygen. Now, if I look at my water molecule, H2O, we know that the mass of the hydrogen is 1 times 2. And if you say, ma'am, where did you get that from? Remember, the atomic mass number of hydrogen is 1. We multiplied by 2 because there's 2 of them. So the mass of hydrogen is 2. If I put that in a ratio with the mass of oxygen in this compound, we know that oxygen's atomic mass is 16. Now look, if I had to simplify that ratio, I divide both sides by 2, I'm going to get 1 to 8. So can you see that the answer is actually 1 to 8? The 1 to 2 and 2 to 1, that's referring to the number of atoms. That's not what the question asks for. They ask for the ratio of the mass. And they specifically say, in the compound H2O, if they ask for the ratio of mass of hydrogen to oxygen in general, then hydrogen's mass would be 1, oxygen's mass would be 16. But we're talking about this compound in particular, so the answer is 1 to 8. In this question, they say 1 mole of H2SO4 sulfuric acid contains, and they give you a whole bunch of things. Now, as soon as you see 1 mole, your brain should be thinking about Avogadro's number, Avogadro's constant, which there it is, 6.02 times 10 to the 23. But if you really wanted to just double check, we know atoms, molecules, molecules, molecules. If you're looking for the number of atoms or the number of molecules, we're going to use this formula. So this is why at the beginning of the video I said, refer to your formula sheet, look at the formulas. If you're working out the number of atoms or molecules, this is the formula you refer to. They say 1 mole of H2SO4. So 1 mole, in the place of N, I'm going to put 1. N is what I'm looking for. That'll give me the number of molecules. And Na, that's Avogadro's number. That's on your formula sheet. It's a constant. It's 6.02 times 10 to the 23. If I take that over, 1 multiplied by 6.02 times 10 to the 23, and that is the number of H2SO4 molecules that I get. Okay, that is why that is the answer over here. Okay, we can't say 1 mole of H2SO4 contains 1 molecule. I just proved to you now that it doesn't contain 1 molecule, it contains this many molecules. I know a lot of you are going to say, but ma'am, the answer is A, 7 atoms. And the reason why you say that is because you look at H2SO4 and you say, I have 2 hydrogens plus 1 sulfur plus 4 oxygens, and that gives me 7. But remember, that is 7 atoms in 1 molecule. 1 molecule. I don't have 1 molecule. I have this many molecules. We just worked out how many molecules I have. So 7 atoms would be correct if they said in 1 molecule of H2SO4. But I don't have 1 molecule. I have this many molecules. Because remember, big N, if you have to calculate big N by using number of moles, which they gave you, you get number of molecules. So that's definitely not the correct answer. And this one just doesn't work out with the calculation. Okay. Our next one, air can be classified as a or as an, and immediately people want to say element or compound. They think that air is a pure substance. It's not. It's not an element. It's not a compound. If I ask you what makes up air, well, you'll say, ma'am, there's oxygen in air. I know that there's nitrogen. I know there's carbon dioxide. So all of these are pure substances. And together, when we mix a bunch of pure substances together, it gives me mixtures. So air is actually a mixture. It is a homogeneous or homogeneous mixture because we can't tell the differences between its components. You can't look at air and say, oh, there's the oxygen, there's the carbon dioxide. It's air. Okay, so uniform composition, all in the same phase, can't distinguish it from one another. So therefore, C. In which ratio will group 1 elements react with group 6 elements? Now let's just take a look at the periodic table. Group 1 elements are these ones over here. Okay, see how the question's phrased. It says group 1 elements to group 6 elements. So let's look for group 6 elements on our periodic table. That's these ones over here. Now we know that group 1 elements have a charge of +1. And group 6 elements have a charge of -2. So I'm just going to write that down for us quickly. Group 1 elements have a charge of +1, and group 6 elements have a charge of -2. Now you might say, okay, 1 + 1 and -2, but now that's none of our options, ma'am. Well, I'm going to pick a random element from each group and show you how they would combine so that the answer makes sense for you. Let's say we have lithium combining with oxygen. Okay, lithium has a charge of +1. Oxygen has a charge of -2. So lithium +1, oxygen -2. What this means, everybody, is that lithium may give away 1 electron to form a +1 ion, a cation, but oxygen needs 2 electrons. So in order to react, in order to form a neutral compound, how many lithium atoms do I need? I need 2 lithium atoms. So it'll be Li2O That means that I need 2 of my group 1 elements for every one of these that I have. I need 2 of my group 1 elements for every one of these that I have. So my answer is A. 1.6 gives us a flowchart to classify some examples of substances P, Q, and R. And they give me a table and they say, what could substances P, Q, and R possibly be? And we have to choose A, B, C, and D. Okay. So our options, as if you look at the table, we can see that we have marble as one of our 3 options, oil, and we have oxygen. Now, right off the bat, we can see that this is a substance and it is most likely trying to divide them into their phases, because you see they speak about definite shape, definite volume, and things like that. So we know we're trying to classify them into solid, liquid, or gas. We know at a room temperature, oxygen will be a gas. We know oil will be a liquid. And marble will be a solid. So they say that if a substance has definite shape, yes, that substance is P. And out of solid, liquid, and gas, which of those 3 phases do we know have definite shape? Our solids, yes. So that means we know that P is definitely marble. Okay. Then they say definite volume, yes or no. We know that gases don't have a definite volume. They occupy whatever volume they are in. If I have to empty out a gas into a room, it'll occupy the entire room. If I have to empty out a gas into an open space, it would just occupy that entire space. But liquids have a definite volume. They take the volume of the container that they're in. So definite volume, yes, that means Q is a liquid, and that means that Q is oil. And then definite volume, no, that means R is my gas, so R is oxygen. And then all that's left to do is just look for the option that suits this. So P being marble, Q being oil, and R being oxygen, it is option A. 1.7 says in a 20-gram sample of molecules, which sample below has the greatest number of moles? Okay, so 20 grams is my mass, 20 grams. If I want to know which one has a greater number of moles, we know that moles is N, baby N. What formula uses mass and baby N? Well, it's this one. Moles is equal to mass divided by molar mass. Okay, so if I say I have a 20-gram sample of molecules, let's pretend all of them have 20 grams, 20 grams, 20 grams, 20 grams, 20 grams. Which of these would have the largest number of moles? Well, if your numerator is 20 grams, the one that would have the greatest number of moles would be the one with the smallest molar mass. Think about that. The bigger the denominator of the fraction gets, if I had to put at the denominator, if I had to put 100 versus if I had to put 1, which of these is a bigger number? 20 over 100 or 20 over 1? Well, 20 over 100 is 0,2 and 20 over 1 is 20. So the smaller the denominator, the bigger the number of moles. So the smaller my molar mass, the bigger my number of moles. And which of these 3 would have the smallest molar mass? Definitely D, because D's molar mass would be 1 times 2. So therefore your answer is D. Carbon dioxide can change directly. The word is directly from the solid phase to the gas phase. This process is known as, this is just pure study work, it's known as sublimation. And if you go from gas to solid, so the other way, that's called deposition. Okay. The chemical name for Fe2SO4 is, okay, now immediately we can eliminate some of these options. We've got iron sulfite, iron sulfate, iron sulfate, iron sulfide. You should know that if it is an Fe and a S, then it's sulfide. Sulfide. So this is definitely not just an S. This is a polyatomic ion, so it's definitely not D. And you should know that SO4, that's the sulfate ion, and SO3, that's the sulfite ion. So it's definitely not that one either. So that means it's between B and C. Now, how we figure it out is we need to figure out what charge iron would have had in order to give this that chemical formula. So iron, we don't know what charge this is, but you should know that a sulfate ion has a charge of -2. But what was it multiplied by in this compound? It was multiplied by 3. Whatever is written here as a little baby number, that is what the charge was multiplied by. So this over here was multiplied by 2. So what was the charge? The charge must have been 3. And how did I know that? So iron 3 sulfate. How did I know that? Well, because this 3 times 2 would be 6. Minus 2 times 3 is -6. It must give me 0. So again, the sulfate ion has a charge of -2. That's study work. So the -2 that I wrote over here, that is study work. You need to learn that. There's a way to figure it out, which I will cover in another video, but for now you can just study it. So -2 is the charge of a sulfate ion. It was multiplied by 3. The little number is whatever the charge was multiplied by. I put it in brackets. I know that the charge of iron, whatever it is, was multiplied by 2. That's why the 2 is going in brackets there. And this was my unknown. So what multiplied by 2 will get me 6? And why do I care for 6? Why am I looking for 6? Because 2 times 3 is -6. So that's why it's iron 3 sulfate. Another way to do this, we know that when we name, a very, very easy way to do naming is the charge swap. So if Fe now has a 2, it means that it swapped that with the sulfate. And we know that that makes sense because the sulfate ion has a charge of -2. And SO4 has a 3 over there, which means that that 3 came from the iron. So basically, whatever that charge originally was, that one goes there and that one goes there, like a little charge swap. This one, the way that this is explained, I know some people explain it like this. I don't really like it because you don't really understand what this means. If you learn it this way, you know that if it has a charge of +3, it means that it can give away 3 electrons. We need 2 of it. If it has a charge of -2, it means that it can accept 2 electrons. We need 3 of it. So this makes a lot more sense. The understanding behind this is a lot better. Let's see if we can figure this one out. The chemical formula for sodium sulfate. Sodium is Na. It has a charge of +1. Sulfate is SO4. It has a charge of -2. So we know that we need to make a neutral compound with a charge of 0. 1 minus 2 does not give me 0. So therefore, I need 2 sodiums, because then that's going to be 2 minus 2, and that's going to give me 0. So it's Na2SO4. Okay? Na2SO4. Whatever you multiply the charges by, that becomes the baby number. And we do not include the charges in the name itself. The only little numbers we include in the name itself is what you multiply the charges by. So sodium can give away 1 electron, but the sulfate ion needs 2. So therefore we need 2 sodiums. During the formation of an ionic bond, electrons are, so the process of elimination, we know that it's definitely not A or B, because A and B talk about sharing electrons. And we know that sharing of electrons, that is covalent bonding. So then that leaves us with C or D, transferred from a metal to a non-metal or transferred from a non-metal to a metal. We know that, for example, an ionic bond, an example would be sodium chloride. That would be an ionic bond. And the sodium forms a charge of +1. The chlorine forms a chloride ion, charge of -1. And that is because the sodium loses electrons. And it forms a charge of +1. And that electron goes to the chlorine. So sodium loses electrons, and we know that because of its charge +1, which means it's lost an electron. Chlorine becomes -1 because it has gained the electron. So ionic bonding is always from a metal to a non-metal. Always. Okay, so C. Right, I have to balance this chemical equation, so I'm going to write it a bit bigger for us. This is our next multiple choice question, and we're going to go as follows. I have 2 hydrogens here and 3 hydrogens here. Okay, so I can think of it this way. In order to make, and I have 4 phosphorus there and 1 over there. So immediately I know, okay, cool. P, this is 4, this is 1. If I put a 4 there, now what did I do? Now I fix the phosphorus, my reactants, and my products, each have 4. Cool. But look at my hydrogens. On my products, I have 4 times 3. I have 12 hydrogens. But over here, I only have 2. So how do I make 2 become 12? I need to multiply this by 6. So I put a 6 there. And there we go. Balanced. So my answer to this is which one of the sets of coefficients will balance this chemical equation. Remember, in front of the P4, I know we didn't change anything there, but there's technically a 1 there. So we've got 1, 6, and 4. So B. And my last question, which one of the following electron configurations represents an ion? Ion of a alkali metal. Now remember, an ion is formed when we lose electrons or when we gain electrons. If we lose electrons, we're going to form a cation, a positive ion. So for example, Na plus or Mg2 plus. That is if we lose electrons. If we gain electrons, we're going to form an anion. Negative ions, anions make you cry, onions make you cry. So for example, the chloride ion or the oxide ion. Now we need to figure out what a alkali metal would form. Would it form a cation, a positive ion, or would it form an anion? Alkali metals are my group 1 metals over here. These are my alkali metals. And we know, look at the charge, we know that they will form +1 charges. They will form cations, which means that they will lose 1 electron. Okay, they will lose 1 electron. So let's see. Over here, we've got 1s2. That represents the electron configuration of helium. If we look at that, 1s2, that would be helium. But that could also represent the lithium ion, because see, lithium has 3 electrons. But if it forms Li+, it means it has lost an electron, which means it'll form 1s2. So that could be my answer. Let's see if anything else makes sense. 1s2, 2s2. So 1s2, I'm going to just clear this mess and I'll show you. 1s2 means that it's 1, 2 electrons. 2s2 means 1. This is energy level 1. This is in energy level 2. This is 2s1 and this is 2s2. So that's referring to beryllium. That is definitely not an ion of an alkali metal. So not B. C is 1s2, 2s2, and 2p5. Okay, so 1s2 would be helium. 2s2 would be beryllium, and then 2p5. This would be 2p1, 2p2, 2p3, 2p4, and 2p5. So we're talking about fluorine. Again, that is not an ion of my alkali metals. So definitely not that one. D, 1s2, 2s2, 2p6, and 3s1. So for a atom ending on 3s1, it means that it is in the 3rd period. So it means we're all the way down here now. This is period 1, period 2. It means we're in the 3rd period. And let's just go back and double check. 3s1. So 3s1 would be sodium. Sodium is an alkali metal. It's not an ion of an alkali metal. So D would probably be the closest guess, but our answer is A. I hope that makes sense. This is a difficult question and you need to understand your SP notations. If this was confusing for you, another way to deal with SP notations is to, for example, if we looked at D, is you add up the number of electrons. So we go 2 plus 2 is 4 plus 6 is 10 plus 1 is 11 electrons. And then you look at the periodic table and you look to see which atom has 11 electrons. And if you look at the periodic table, you'll see that that is sodium. And then you can ask yourself, well, does sodium fit this description? And no, sodium doesn't fit this description because sodium is an alkali metal, but the question wants an ion of an alkali metal. Okay, so if you looked at this one, this is the correct answer. We can see 2 electrons. Just because it's 1s2, 2 electrons, and we know that that represents helium. And helium has 2 electrons, which means that it could be an alkali metal that has lost an electron. So again, if I have to look at the periodic table, if lithium which is an alkali metal, had to lose an electron to form Li+, because it would form a +1 charge, it would lose 1 electron. It would no longer have 3 electrons, it would have 2 electrons. Yay! Which means its electron configuration would be 1s2. Difficult question, but if you need more help on electron configuration, I do have a video on that, so make sure to watch that. I hope that you learned from this video, and please let me know if you'd like to see more like these. And I hope to see you guys in the next video. Bye everyone!